Computer adaptive tests like the ILEARN assessments are designed to adjust difficulty based on a student's responses. This means the test gets harder when a student answers correctly and easier when they answer incorrectly. The performance level descriptors organize each Indiana academic standard into 4 levels that align with ILEARN proficiency. Here's a simplified example of how the assessments can make adjustments through one academic standard using the performance level descriptors and item specifications. Let's say a 3rd grade student starts a math checkpoint on the approaching proficiency level for standard 3.NS.6. If they get the first question wrong, the next one for that standard will be easier, such as a below proficiency item. If they get it right, the next one will be harder, such as an at proficiency item. A key part of this process is determining where to start a student on the test, or their initial ability estimate. If any previous performance data is available, it can be used to set a more appropriate starting point. If a student has a paused test and is now resuming it, the system will use their most recent progress as the starting point. If a student is starting a new ILEARN checkpoint or summative test, but has already taken a checkpoint this year, the system will use the most recent checkpoint score to determine the difficulty of the first question. For students who have no previous test data, such as those new to the state, the system will use the average score for all students in the state as a starting point. This will place them at a medium difficulty level for the first question. Here's how this might look on the ILEARN through-year assessments. When a student starts checkpoint 1, the first question is at a medium difficulty level. The test then adapts quickly, usually within 3 to 5 questions, to find the student's true ability level. It continues to adjust throughout the test based on the student's answers, and they will finish with a performance level such as approaching proficiency. For checkpoint 2 and subsequent tests, the system uses the student's most recent score to set the initial difficulty. For instance, if a student scored approaching proficiency on checkpoint 1, they would start checkpoint 2 on items that are at an approaching proficiency level according to the performance level descriptors. The test will again adapt quickly based on their responses, and this process continues all the way through to the summative assessment. Some may worry that using a student's checkpoint score as a starting point could unfairly influence their final ILEARN summative score. However, data scientists from CAMBM have confirmed that this is not a major concern for the following reasons. 1, the test algorithm is designed to quickly adjust after each question. This means it continuously refines its estimate of a student's ability, regardless of where they start. 2, the ILEARN tests are long enough for the adaptive process to work effectively. Even a mismatched starting point will be corrected over the course of a test. And finally, a simulation proved this point. Students given artificially high or low starting points ended up with final scores nearly identical to those who started at an accurate level. Here are some benefits of using previous checkpoint data as a starting point. By using checkpoint data, the ILEARN assessments can zero in on the student's ability faster, making the scores more precise and dependable. Starting with questions that are more closely aligned to what the student already knows means fewer wasted items early on, which in turn leaves more items targeted to the student's ability. Research also shows this method is especially supportive for students with low confidence levels. By starting with items they are more likely to be successful with, the testing experience feels less intimidating and more encouraging. For example, a student who is typically performing at below proficiency won't have to start at a medium difficulty level and then miss several questions in a row to start the test. Instead, the test will begin with items at their current ability level, creating a more positive and successful testing experience. By leveraging a student's previous checkpoint scores, the adaptive assessment process becomes more efficient and accurate at finding a student's true ability level. This approach results in a more precise final score without unfairly affecting it. Ultimately, this method helps create a more supportive and less intimidating testing experience, particularly for students who may lack confidence.